Again, the Let's Talk Chemistry with Pastor Dan. We're looking at solutions. Remember, solutions are homogeneous mixtures, solute and solvent. Solid substance dissolved. Solvent is the substance doing the dissolving. Now we're looking at concentrations today. Now concentrations, there's a lot of different of them. We've got assay, which is percentage. We've got ppm, parts per million, ppb, parts per billion. We've got something called normality, which I don't get into at this level. I'm only going to do with 2 units of concentration. So that way we keep it simple. We're getting towards the end of the year, but it's the ones I use most often in a chemistry class. The first unit of concentration that we're going to use is called molarity. Now, molarity is defined as the moles of solute over liters of solution. Now, remember, the solute is a substance that's doing the dissolving. When we do that, we use a capital M to represent molarity. So whenever we talk about it, we would put down a capital N, say that we're using molarity, and then we include the solute. All right, so let's look at a problem here. So calculate the molarity, we want to find it, of 17.65 grams of sodium chloride in 350.0 milliliters of solution. Now, molarity again is moles of solute over liters of solution. Now, what's my solute? If we look at the problem, the only thing listed here is sodium chloride, salt. There we go. All right, now, we're going to take our value here and put it over 1. Now, what are we going to go to? We got to go to moles. So therefore, we take the formula masses of each one defined, the atomic mass of each one defined, the formula mass. So start with sodium, 23 grams, chlorine, 35.5. Remember, we keep copper and chlorine at 0.5. Adding together, we get 58.5 grams of sodium chloride is 1 mole. All right, so we're going to convert grams to moles. Grams go on the bottom, cross out moles on top. When we do that, we get 0.3017 moles of sodium chloride. Now, how do we get that again? 4 sig figs is 17.65. 58.5 is definitely significant, and of course 1 is definitely significant. So we have 4 sig figs. Now that takes care of my numerator. Now my denominator, I want liters of solution. The other problem says there's 350.0 milliliters solution. I use abbreviation SOLN instead of writing the whole word solution. We want that in liters. So 1 liter is 1,000. Remember, milli means a thousandth of. So 1,000 of them is 1 liter. Multiply through, we get 0.3500, 4 sig figs. That value is going to go right there. Plug it in, divide 0.3017, grab in your handy dandy Joe Dandy calculator, do your gazinthesis. This goes into this. Multiply through, we get 0.8620, needing 4 sig figs. That's my answer. All right, now there's another kind of problem we can also do. I can give you a problem like this. Find the mass of copper 2 sulfate needed to make 250.0 milliliters of 0.7550 molar solution. Now, there's a rule that I always teach my kids. We never, ever, 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 never, ever, 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 never, ever, 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 you're getting the point, we never start with a concentration. Why? Because we're going to use that concentration as a unit converter. We're going to use it to get out of something and into something. So we always got to start with, and since that's my concentration, we start with the other value. The other value is 250.0 milliliters. Now, as a general rule, something to help keep you straight here. If I'm in solution, I want to go to liters. The other things we understand, if it's in solute, it goes to moles. And if it's in solvent, it's going to kilograms. So we're in solution, we want to go to liters. Remember, 1 liter is 1,000 milliliters. Now, why do we do that? Because we said we had molarity. We had 0.7550 molar copper 2 sulfate, copper plus 2, sulfate minus 2, CuSO4, formula mass there. We want to make that into a unit converter. So how are we going to do that? Well, easiest way to do that is say, okay, let's say I have 0.7550 moles, then how many liters would that have to be? That'd have to be 1. Now, I'm in liters, so liters are going to go on the bottom, moles on top, and we slide it up like that. So my liters cross out, I'm now in moles. Now I want mass from moles, that's going to require formula mass. So I have copper, sulfur, and oxygen. Copper's atomic mass 63.5, sulfur's 32, oxygen 16 times 4 64. Add them up, I get 159.5 grams of CuSO4 is 1 mole. I want to get moles out, so mole goes on the bottom, grams go on top. Take your calculator, type in 250.0 times 0.7550 times 159.5 equal, divide by 1,000 equal. When we do that, check our sig figs. I got 4 infinite, so 4 is at least a number. We end up with 30.11 grams of CuSO4. All right, now, I said there are 2 units we're working with. We looked at molarity. The other one we're looking at is concentration unit of molality. Now, molality sounds an awful lot like it, so we have to make a different symbol. Remember, we said capital M was molarity, small m is molality. It's the moles of solute now over kilograms of solvent. And solvent, again, substance soon dissolving. All right, so let's determine the molality. So we're going to do this simple way of 348.95 grams of lead 2 nitrate and 300.0 grams of water. All right, now, molality again is moles of solute over kilograms of solvent. So we got to take our solute here and lead 2 nitrate, lead is Pb, nitrate inside or outside the box. Remember, periodic chart, nitrate is outside the box chart, O3 outside the chart, so we get NO3. Oxidation numbers, lead is +2, nitrate is -1, so we get Pb, parentheses, NO3, close parentheses, twice. All right, so we got to take that solute in grams, and we got to go, remember that's a solute, it's going to go to moles. So lead is 207, nitrogen is 28 because there's 2 of them there. 6 times 16, 96 grams. So we have 331 grams of lead 2 nitrate is 1 mole, lead 2 nitrate. We put grams on the bottom, moles on top. Take your handy dandy Joe dandy calculators. 348.95 divide by 331, 5 sig figs. I get 1.0542 moles of PbNO3. Now again, it's moles over kilograms. So if I have 300.0 grams of water, 1 kilogram is 1,000. Kilo means 1,000 of. So we end up with 0.3000 kilograms, 5 sig figs, 4 sig figs. So least number is 4. I end up with 3.514 molal, small m, of PbNO3 twice. Now I remember that 2 types. We're going to do the same one here. This time we're going to want to find the mass of water needed to form 1.285 molal sodium hydroxide if there's 15.97 grams of solid. Now again, never start with a concentration, so we're not starting with that number. Start with the other number, 15.97 grams of my solid. Well, what's my solid? Look up here. In the solution, it's sodium hydroxide. Sodium hydroxide, OH, +1, -1, there we go, over 1. Formula mass, sodium's 23. Oh yeah, man, solid has to go to solid, which means we got a moles. All right, so sodium's 23, oxygen 14, hydrogen 1, adds 40 grams is 1 mole, grams on the bottom, moles on top. Now, again, we don't start with a concentration, so we can use it as a unit converter. So if I have 1.285 molal, we're going to do the same thing we did last time. We're going to put the units over 1, so therefore I would have 1.285 moles of NaOH over 1 kilograms of water. But this time, instead of just sliding it down, we're going to flip it over so my moles will cross out, and it'll be in kilograms. So 1 kilogram of water over 1.285 moles of water of sodium hydroxide. Now, I could leave it there, but most people don't measure things in kilograms, so let's go one more fraction. Let's go to grams. 1,000 grams is 1 kilogram. Take your calculator, 15.97 times 1,000 equal, divide by 40 equal, divide by 1.285 equal. Give you a few seconds to do that. Check our sig figs. I have 4 infinite, least number is 4, so I get an answer of 310.7 grams of water. That's my answer. All right, let's try a couple of these. So there's 2 problems I want you to work through. When you do these, please pause the video and see what we come up with, and we'll go over the answers here at the end, okay? All righty, let's see what we get. Ready? Here we go. So the first one, we're going to find the molarity. So we convert grams to moles. Formula mass of silver nitrate is 170 grams. 0.1174 divide by liters into milliliters into liters, divide by 1,000. We end up with 0.43725 molar, capital M, AgNO3. For the second one, again, I'm giving you a concentration. We're not going to start with them. That's my solute. Solute goes to moles, and then moles of kilograms, and I'm asking in grams, so I convert it that way. We end up with 2,026.2 grams of water. All right. Hopefully that wasn't too bad. Take care. God bless. Be good.